Space elevators are one of those technologies that sci-fi nerds like me obsess over. They straddle the line between outlandish impossibility and genuine engineering potential. It's a technology that could cross the divide of science fiction to science reality if we somehow improved on existing technologies. A space elevator is exactly that, a giant elevator shaft that we can climb to reach space, eliminating our dependence on rocket fuel to reach orbit and hopefully, in the process, lower the cost of space travel. This isn't your typical construction that relies on the compressive strength of a material to remain standing. Our buildings are largely restricted in height as a result of the compressive strength of our building materials. The higher we build, the more weight is piled onto the foundations of the building. We can counteract this by widening the base of the construction to spread the weight over a larger area and then taper the building as it rises to reduce the weight being added as we add more floors. If we widen the base, but this becomes uneconomic pretty quickly as the base would take up an unreasonable amount of space. So, how would a space elevator solve this problem? By counterbalancing the weight of the structure by pulling upwards. We can do this thanks to centrifugal force. Imagine a tetherball swinging around a pole. At a certain angular velocity, the string will be held straight and taut against the pole, because centrifugal force, an apparent force that appears in a rotating reference frame, pulls outwards. Now, the problem is, the whole point of tetherball is to wrap the string around the pole. If the string can't rotate around the center of spin, it will simply wrap itself around the pole. We are essentially trying to recreate this dynamic, but on an astronomical scale, and to do that, we have to work with the Earth's natural rotation. So, our structure will need to be located on the equator. Let's imagine a base located in the middle of the Atlantic Ocean. From here, we're going to draw a straight line out into space. For now, this is just a line, no structure exists. But any structure that is constructed will need to exist along this line. If it is not in sync with Earth's rotation, the structure will curve and break, or in some sort of cartoon world, wrap around the Earth like the tetherball example. Our orbit will need to be circular rather than elliptical, as an elliptical orbit would require a tether capable of constantly changing length without breaking. But we would still have to solve a huge number of engineering challenges. Eliminating vibrations and waves propagating through the tether is a huge challenge. Powering the climber and dealing with the adverse weather of the lower atmosphere and dodging space debris in orbit